overview of what probability is. So basically, we've been doing simple things like toss a coin, and the outcomes are head or tail, or roll a die. You get 1, 2, 3, up to 6, etc. These are one-stage experiments. Today, we're going to do two things at once, such as tossing two coins. What are the outcomes? Or roll two dice. That's what we're going to do. And to list the outcomes, we'll use what we call an array. Okay, so we're going to use an array to list the outcomes for two-stage experiment. So let's look at when we roll two die. At first, I roll one die, but you roll it twice. Okay, so you're going to use an array to list the sample space of an experiment. So to do that, we can split that into first die and the second die. Let's use the red one for second. First row and second row. So you roll the first and the second row. So what you do is, when you roll the first, the outcomes could be 1, 2, 3, 4, 5, 6. But if you roll it again, you will also get the outcome 1, 2, 3, 4, 5, 6. And what are the combination? What are the possible outcomes there? In fact, a lot more than 6 outcomes, because you can combine the first row, which is in blue, with the second row of 1, right? So you can write it as an ordered pair. And the second way is it can be 2, and the second row could be 1, again, like that. And then you can list them all, so close, 3, 4, 5, 6, and then the second row could still be 1. So these are all the possible outcomes where the second row is 1. Or it can be like this. Your first row could be 2, but the second row could be 2, like that. So all the second row is 2. Oh, 1 and 2, you're right. Okay, whoops. 1 and 2. 1. Oops. 1 and 2. 2, 2, 3, 2, 4, 2, 5, 2, and 6, 2. Now complete the rest. Complete the rest. So you get 1, 1, 1, 1, 2, 2, 2, 2. Right? So the blue number represents the first toss. The red number represents the second toss. So you can distinguish between them. So when you get the outcome 1, 2, it's different from getting 2, 1, because 2, 1 represents first toss is 2, second toss is 1, whereas 1, 2 means the first toss is 1, the second toss is 2. So note the difference between them. Right, so let's complete the let's complete the table. So you get 3, 4, 5, 6, and then the other one will be 3, 3, 3, 3, 3, and then 4, 4, 4, 4, 5, 5, 5. So using an array, you can be sure that you do not miss one outcome. All outcomes are listed systematically, so you won't miss any outcomes. Okay. All right, now once you draw the table, we can answer questions. The first question we should ask ourselves, how many outcomes altogether? How many are there? 36. Another way to do that, you can just count by doing 6 times 6, which is 36. So 6 times 6, 36 outcomes. And this is important because when we calculate probability, 36 will be in the denominator of the fraction. So now we can find the probability of getting a double. What's a double? Two rows that are the same. Very good. All right, let me just highlight the ones that are acceptable. So these are the. I skip it. Oh, oops, sorry. Okay, so we'll just go down. Let's do this first, and we'll go back. Sorry about that. Okay, so for double will be 6 out of 36, which is 1/6. Now going back to this one, find the probability of outcome 1/5. So 1/5 will be just one, which over here, right? So it will be 1 out of 36. Yep. Okay, any questions? So it's all pretty easy after you list the outcomes. Let's continue. Find the probability that the sum is at least 10. Sum is at least 10. So that means if you add the numbers, it has to be 10 or more. So which one would it be? So let me use a different highlighter. So the next time, maybe I could use this one, green. Okay, sum at least 10. So which one will it be? So 10 will be 4 plus 6 is 10. 5 plus 5 is 10. 4 plus 6, and of course everything here, right? Good. So what would that be? So the answer will be 6 out of 36, which is also 1/6. All right. And the last bit says sum not equal to 7. When they say not equal to, it's easier to calculate the complement, which is 1 minus equal to 7. Like that. All right, which one's equal to 7? 1 plus 6. So let's use a different highlighter. Goes the other diagonal, isn't it? So is there more color for... okay, let's use purple. Okay, this one, right? These are all 7s, but remember you have to subtract. So how many are there? 1, 2, 3, 4, 5, 6. So it will be 1 minus 6 out of 36. And if you simplify, you get 5 out of 6. Okay? All right, question. All right, after we do this, it says find the probability of a sum of 12 given the sum is at least 10. This is conditional probability that will know that it must add up to at least 10. And given it's at least 10, we need to know when is the sum, what's the chance going to be equal to 12. Okay, so you look at the ones in green, right? These are at least 10. Which ones add up to 12? 1, but will be 1 out of 6 rather than 1 out of 36. Because we know it's at least 10, there's 6 outcomes. 6 outcomes. 6 outcomes that are at least 10. Out of the 6 outcomes, there's only 1 outcome that are out of the 12. Okay, good. After we do this, we'll do another example. This is a die problem. So this array method can be applied for any 2-stage experiment. So the next one involves selecting 2 letters from the word kick without replacement. Okay. We need to understand what the word without replacement means. Okay, let's look at that or finish. Okay, good. All right, let's look at this question. 2 letters are chosen from the word kick. Okay, so that means you could write it as the first letter, which can be any letter from the word kick, K, I, or C, or K again. And the second letter, which I'll also use red again, can also be K, I, C, K. So that's what you do when you do 2 things. When you select 2 letters or rolling a die twice, is to draw a table like this, and then the outcomes in the first and the outcome in the second are exactly the same. Okay, so you just find all the possible pairs with the first letter and the second letter. Okay, so now be careful. We say without replacement. That means once you select a letter, you can't select the same letter again. So that means if I select the letter K, I can't select second letter as the same K. So that means everything here are not possible. You can't have double. As in you can't select the same letter twice. Cannot select same letter twice. That. Okay, now we have to list the other pairs that are possible. So that means it's going to be, in my first letter is I, the second letter could be K, right? Or if the first letter is C, the second letter can also be K. Or the first letter could be K, the second letter will be K. Alright, like this. And then list all the other outcomes. So all you have to do is just copy the heading. Everything is KK. But then the second letter can vary from I, C, and then K. Like that. And then you just go like that. Let me use a different color for this. Okay. Let's get rid of the cross. Say again. Now this K is different from the other K. So this is the first letter K, that's the last letter K. So there's two K. So it's possible to have doubles. See, that blue K means the K from the first letter, but the red K is the, oh no, that K is the K from the last letter of the kick, whereas the red K is from the first letter of the word kick. Yeah. So this is different from doing this KK. Right. Okay. So we're going to continue. So C, C, K, K, I, I. And then we're going to go K, no, I, C, and then K, and then I, and then C, and then K. Yeah. Now to make it easier, you can just number the K. So you can call this K number 1, K1, this is K2, right? So basically this is K2 pairing with K1. So it's a different K, not the same K. Whereas this one, you try to pair the K1 with the K1, which is not possible. Okay. All right. Now in this case, you need to list how many outcomes before we answer the probability. So how many outcomes altogether? 12. Yeah, because it's 16 minus 4, isn't it? So there are 12 outcomes. And now we can answer the probability. What's the probability of getting KC? KC is, yep, 1/6, because KC, let's do it in a highlight. Get my highlighter. So KC is here. Are there other KC? Yeah, there's 2 KC, right? Because you can involve the first K or the last K. Okay, so it will be 2 out of 12, which is 1/6. What's that? Selecting 2 Ks. Which one has got selecting 2 Ks? 2, so KK here and KK there, right? So it will be 2 Ks. So it will be 2 out of 12, which is 1/6 again. All right, how about selecting a K and a C? Well, that's different from K. That can be KC or CK, right? It doesn't say which order it appears. So now we have to include the CK as well. So it will be 4 instead of 2 out of 12, which is 1/3. Yep. All done. Good. One more question. Selecting 2 Ks given at least 1 K is selected. Remember, conditional probability. Selecting 2 Ks given at least 1 K is selected. At least 1 K selected, you have to get 2 Ks. Okay, so to answer this question, we need to know how many of the outcomes has got at least 1 K in it. So what are the outcomes? So let me circle them. This has got 1 K in it. This has got 1 K in it. And these ones. So how many outcomes has got at least 1 K in it? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So at least 1 K selected means 10. Out of the 10, how many have got double K? 2. So it would be 1/5. Excellent. So the exercise for today is 3E. There's still plenty of time before scripture. Start now, 3E. Thank you. 11 o'clock we'll pack up. Okay? Off you go.